Welcome back. Does everyone around the world have the same access to energy? We will discuss that in this video. The learning objectives are to get a feeling for the typical energy consumption per capita around the world and what is the role of access to energy on the living standards and the economic opportunities. What is the current status of electricity access around the world? On average, every person on planet Earth consumes the amount of 65 kilowatt hour per person per year in the form of primary energy. This includes the energy consumption in all sectors like industry, transport, households, agriculture, and public service, etc., etc. To put this number in perspective, a mature human male person consumes chemical energy per day in the form of food that equals the amount of 2.9 kilowatt hour per day per person. This means that we consume per person 20 to 25 times the amount of primary energy that we need to stay alive in the form of food. However, 65 kilowatt hour per day per person is a global average. The distribution of access to energy over the world shows some inequalities. For instance, a citizen in the Netherlands consumes 2 times more primary energy in reference to the world average. A citizen in the US consumes 4 times more primary energy in reference to the world average. Whereas a citizen on the African continent, on average, uses a fifth in reference to the world average primary energy utilization per person per day. I can show it in more detail on this world map. The colors represent the primary energy consumption per person per day in a country. These dark colored countries have the highest primary energy consumption per capita. A few countries in the Middle East region have energy consumptions above 300 kilowatt hour per day per person, which is related to the easy and cheap access to their own fossil fuel reservoirs. In the USA, Canada, Australia, Saudi Arabia, and some countries in Europe, the citizens consume around 200 to 300 kilowatt hours per day per person in the form of primary energy. Citizens in Japan, Russia, and some additional European countries are in the 120 to 200 kilowatt hours per day per person range. All countries colored up to now in the world map are the countries that consume equal or more than the global average of 65 kilowatt hours per day per person. The countries that are getting lighter colors now on the map are the countries in which citizens consume less primary energy than the global average. The lightest colored countries in this map represent the countries in which a primary energy consumption per day per capita of 8 to 19 kilowatt hours per person per day. Among these countries is, for instance, India with a population of around 1.3 billion people. Note that the energy consumption in many countries in Central Africa are smaller than 8 kilowatt hours per person per day. Energy access plays a dominant role in the Sustainable Development Goals of the United Nations. The 2030 Agenda for Sustainable Development, adopted by all United Nations member states in 2015, provides a shared blueprint for peace and prosperity for people and the planet now and into the future. At its heart are the 17 Sustainable Development Goals, which are an urgent call for action by all countries developed and developing in a global partnership. They recognize that ending poverty and other deprivations must go hand in hand with strategies that improve health and education, reduce inequality, and spur economic growth, all while tackling climate change and working to preserve our oceans and forests. Sustainable Development Goal 7 is focused on clean and affordable energy for everyone. In the SDGs, energy is finally being recognized as a key enabler for development. Universal access to energy, a higher share of renewable energy, and massive improvements in energy efficiency are now part of the top global priorities for sustainable development in the years to come. Energy is crucial for achieving almost all the Sustainable Development Goals, from its role in the eradication of poverty through advancements in health, education, water supply, and industrialization to combating climate change. Let's look in more detail to the role of energy access. What is the relation between energy access and economic prosperity? Let's use the economic metric of gross domestic product per capita and the earlier introduced daily primary energy consumption per capita. The gross domestic product is the total monetary or market value of all the goods and services produced within that country's borders during a specific period of time. Usually the period of a year is taken. Every circle in the graph represents a country. The size of the circle scales with the country's population. The two largest circles correspond to China and India. The graph shows that economic prosperity scales with the access to energy. A large gross domestic product per capita requires a country that has access to energy, or in other words, has an excellent energy infrastructure. Whereas countries with a low gross domestic product per capita will have a less advanced energy infrastructure. The access to energy therefore relates with the type of society. Let's consider various types of societies, going from a hunting society to a primitive agriculture society, to an advanced agriculture society, an industrial society, and a modern society. I would like to emphasize that the industrial and modern society are not better societies than the other ones. In terms of sustainability, these latter two societies, in my personal view, will be inferior to the other societies. Now we start plotting the daily energy consumption per capita as discussed before in this plot. We see that in some regions in the world, the energy infrastructure needs to be further improved to make advances in the earlier discussed Sustainable Development Goals. This can be done by the introduction of photovoltaic system that helps to establish societies towards an advanced agriculture or even a future sustainable industrial society. Renewable electricity is an important energy carrier to modernize any society in a sustainable manner. This graph shows the progress made in the 21st century so far. The people with no access to electricity, the red colored bars, have been halved from 2000 to 2019. That is a welcome and positive trend, considering that the world population has grown with 1.6 billion people in that same period. However, around 0.8 billion people, or 800 million people around the world, still lacks access to electricity. Another 1 billion receive an unreliable electricity connection. Coincidentally, most of these affected communities and regions lie in the equatorial and tropical latitude belt, as can be seen in this map. Therefore, a solar-based solution for providing electricity seems to be an obvious choice. This is currently being done in the form of solar home systems, which comprise of solar panel and battery to power certain appliances. However, although it's a no-brainer that photovoltaic systems is a fast and sustainable route to improve living standards and create economic opportunities in these rural regions, we still have to realize that the present solar home systems suffer from two major challenges. The first challenge is related to the fact that the solar home systems are being optimally designed for a particular set of appliances. Let's say the system consists out of one or two panels. However, energy access is not a binary state, a have or a have not condition, as envisioned in the past. It's a multi-tiered state. Additionally, the intended consequence of electrification, which is to increase the quality of life, is also an unintended consequence. This is because the increase in standard of living comes with increased electrical demands, or the so-called climbing the rural electrification ladder. Thus, a system perfectly designed for a particular set of appliances is rendered obsolete as the user climbs the electrification ladder. A strategy to scale the capacity of solar home systems in time needs to be included. The second challenge is related to the fact that there is an optimal range of operation for present solar home systems, costs versus power, as seen in this graph. On the vertical axis, the cost of appliances is plotted, and on the horizontal axis, the power of a typical solar house system in rural areas. There are some appliances which might be out of reach in terms of purchase power of the people. But at the same time, there are some appliances that are very much within the purchase power, but out of the power range of the solar home system. For example, there are households that might be clearly capable of buying a water kettle that costs a few dollars. However, they are almost 5 to 10 times the peak power rating of a typical solar home system consisting out of one solar panel. In summary, in this video I have discussed the worldwide access to energy and electricity in the world and the role it plays in the people's living standards. Photovoltaic systems, here presented in the form of solar home systems, are a logic route to further improve the access to electricity in rural areas in the world. However, how simple it might sound, we have to realize that the so-called climbing the rural electrification ladder also has its challenges. I hope that this video inspired you to contribute to the goal to realize a world in which everyone has access to clean and affordable energy. So, see you in the next video.